It was the Soviet Union versus the United States. The technological advances of the space race rippled through society. Computers, satellites, materials, missiles. But its greatest legacy may not be something we made. Rather, it's a collection of rocks that astronauts picked up off the surface of the moon. They have led to a whole new understanding of Earth's early years and of our moon's mysterious beginnings. It's the brightest object in the night sky. For millennia, the moon has defined the rhythms of life and animated our myths. It has played a central role in our planet's history by stabilizing Earth's rotation about its axis, and with its tides promoting the formation of ocean currents that shape our climate. And yet, within its brilliant light is one of the most vexing questions in all of science. Where did the moon come from? At the dawn of the space age, in the 1950s, there were three competing theories about the moon's origins. One held that it was part of the Earth, cast off by the rapid spin of our planet in its early days. Another saw the moon as a wayward object that floated through our solar system and was captured by Earth's gravity. A third idea held that the moon formed right alongside the Earth. Scientists from the Soviet Union and the United States sought to test these theories with a fleet of unmanned lunar probes, shooting pictures, taking readings, and crashing onto its surface. To settle the question, we needed to go down onto the surface of the moon, to see it with our own eyes, and bring a piece of it back to our labs on Earth. But the quest to obtain samples from the moon was fueled as much by science as by competition between the two nations. The race to space began on October 4th, 1957. When the Soviet Union launched a satellite called Sputnik, higher and faster than anything before it. Sputnik's beep was a wake-up call for the United States. It led to the creation of NASA and a mission to get an American into space. The Soviets then launched Sputnik 2. It was 6 times heavier and had a passenger, a dog named Laika. Surprising the world again, the Soviets launched a spacecraft on April 12, 1961. that carried a man into space, cosmonaut Yuri Gagarin. From 1957 till 1965, the Soviets routinely bested their American counterparts. To overtake the Russians, President John F. Kennedy had to aim high. He committed the United States to the goal of landing a man on the moon before the end of the decade. Nothing so grand is ever so easy. The Gemini program was set up to build the skills and technologies needed for a successful lunar mission. It had its share of mishaps and failures. The Soviets were working on their own moonshot with the giant N-1 launcher. It had a complex design that included 30 engines on its first stage, all of which had to work flawlessly and in sync. Testing on the different stages of the N-1 started in 1968, followed by 4 full-scale unmanned launches. Meanwhile, the American lunar program pinned its hopes on the mighty Saturn V rocket. The first manned launch of the Saturn V would carry the Apollo 8 capsule to the moon and into lunar orbit. Apollo 8 coasted to the moon and successfully returned. Both nations now had a lunar landing in sight. On July 13, 1969, the Soviets launched Luna 15, the third in a series of robotic craft designed to land on the moon, analyze lunar dirt, and fly samples back to Earth. Apollo 11 blasted off 3 days later. Luna 15 arrived on schedule, but Soviet controllers kept it in orbit to check its onboard systems. On July 20, 1969, Neil Armstrong and Buzz Aldrin began their descent to the lunar surface. Computer overload alarms caused the Eagle lander to overshoot its designated landing site. Flying above boulders as big as houses and running low on fuel, Armstrong took manual control and searched for a spot to touch down.
Four forward, drift into the right level. Pound and a half, 30 seconds. Contact light. Okay, engine stop. We copy you down, Eagle. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again.
The 2 astronauts were out on the surface about 20 minutes later. Just as the American astronauts completed their first walk, Luna 15 finally began its descent. But within minutes, communications ceased. The thinking is that it crashed into the side of a mountain. Neil Armstrong called stepping onto the moon a giant leap for mankind. But it's what he and other astronauts picked up that may turn out to be Apollo's greatest legacy. On this and 5 subsequent missions, the astronauts entered a world that's frozen in time. In the absence of an atmosphere, the rocks, dirt, and craters held evidence of events dating back nearly to the moon's birth. Meanwhile, as they walked and rambled about, scientists on Earth were taking a fresh look at the lunar surface. They noticed, for example, that some large old craters are surrounded by concentric rings. You can see them in this image of a feature called the Mare Orientale, captured recently by NASA's Lunar Reconnaissance Orbiter. The colors show differences in elevation. Scientists began to suspect that the rings were created when an impactor splashed down on a molten surface. That gave rise to the notion that early in its history, the moon's surface was a vast ocean of magma. When the astronauts arrived, they found relatively light rocks strewn about the surface. They could have been forced to the surface by heavier material that had sunk toward the moon's interior. The rocks contained another important clue to the moon's origins. They were found to be strikingly similar to those on Earth, in part because they share forms of oxygen that scientists regard as blood types for solar system bodies. A striking new theory emerged to explain the evidence. Early in the history of the solar system, the theory holds, Earth shared an orbit with a Mars-sized body called Theia, named for a titan in Greek myth who gave birth to the moon goddess Selene. When its orbit became unstable, it headed in Earth's direction. Theia hit at an oblique angle, causing the Earth to spin faster and debris from both Theia and the Earth to fly into orbit. When the dust settled, the debris began to coalesce in Earth orbit, forming the moon. By then, volatile compounds like water had evaporated. The moon then comes primarily from the mantles of the Earth and Theia. That's why, on the whole, it's lighter or less dense than Earth. From this violent beginning, the moon gradually cooled and the magma that lined its surface hardened into a crust. Yet it was still subject to intense bombardment in the chaotic environment of the early solar system. The Apollo astronauts encountered a secondary effect of all the impacts. Rocks that were formed in the crucible of widespread volcanism. On Earth, volcanic eruptions are often powered by water, heated and pressurized during the movement of immense tectonic plates. Volcanism on the Moon is tied to impacts forceful enough to melt the surface and release material from the hot interior. When this happened, molten rock flowed out in thin, smooth layers that reached far from its source. That's how the mare regions that cover about 1/6 of the entire lunar surface are thought to have formed. These immense volcanic basins date back to a period of large and violent impacts from 3 to 4 billion years ago. It now appears that impacts had made an even deeper impression. One new study seeks to explain the Moon's lopsided topography. The dark lava basins on the near side and the highlands on the far side. It holds that another, much smaller body formed alongside the Moon at the time of its birth, and eventually merged with it. The violence of the merger literally rearranged the Moon's interior, pushing molten magma onto the near side, while adding an extra layer of crust to the far side. Apollo astronauts took the first step in studying the interior of the Moon by installing a network of seismographs. Scientists recently followed up by performing a kind of CAT scan of the Moon. They sent out a pair of spacecraft called GRAIL to orbit the Moon in unison. By measuring subtle changes in the distance between the craft, scientists can discern variations in the Moon's gravity. What they found was that the Moon's gravity is not smooth. Rather, it's pocked with regions that exert an especially strong pull. GRAIL scientists have now linked these regions to dense concentrations of mass deep inside the Moon, and these to large impact sites such as the Mare Orientale. Lunar impacts appear to have left an even more remarkable legacy. In the year 2009, the L-Cross probe arrived at the Moon aboard the Lunar Reconnaissance Orbiter on a collision course with the South Pole. It slammed into a crater. Seconds later, a trailing probe detected a tenuous cloud rising up from the crash site. Readings of this cloud showed that 5.6% of the crater floor consists of water ice. Most likely, It was delivered by comets that crashed into the moon. It had survived over the eons in craters with steep sides that shield it from the sun. It turns out that may be just the beginning of vast hidden stores of water. Circling the moon repeatedly aboard the Lunar Reconnaissance Orbiter, a Russian-made instrument called LEND has found evidence that hydrogen and perhaps water ice is embedded in lunar soils beyond the polar craters. And now, rocks picked up by the astronauts are telling an even deeper story. Analyzing them with new techniques, several teams of scientists recently found a compound called hydroxyl. It's H2O, but with only one atom of hydrogen. Based on this evidence, scientists estimate there is enough water locked up inside the moon to cover its surface in a layer 1 meter deep. The intimate connection between the Earth and the moon appears to trace back to their earliest times. So far, we've really only scratched the surface of their shared history. The quest to understand that relationship was once part of the feverish competition of the Cold War. A whole new race to the moon is now heating up. This time, fueled by the search for valuable minerals and metals, mining and money. Russia, the United States, China, India, and Japan all have missions in development, including an array of manned missions.
Discovery's engines are now throttling down as the orbiter passes through the area of maximum pressure, reducing the stress.
A number of private missions are also on the drawing boards. What will these missions tell us about our celestial partner and how it formed? Inevitably, the more we learn about the mysterious birth of the moon, the more we'll learn about its mother planet, Earth.